to everyone. So before going to the topic, you know that for all the ENP companies, the waste disposal is a major concern. In fact, this is one of the main agenda in the corporate social responsibility. In the panel discussion just now earlier about the operational reliability, there was a question that okay, there is a commitment from the companies, oil companies for the safety, but there is no commitment for the environment. But we wanted to show here one of the company, this is Untitled company, which is doing best available technology and ensuring the zero discharges to the environment. I am going to present here about the ADCO drilling waste management practices. And also we are not only happy with what we are doing, also we are continuously exploring and striving to explore new technologies. Yeah, the ADCO is a major ADNA group company. It is responsible for the onshore and shallow water oil and gas operations. It is producing about 60% of the production of the UAE is produced by ADCO. The crude production for the last year was about 1.5 million barrels a day. Last year we drilled about 250 wells and the total depth was about 1.6 million feet depth. So you can imagine what will be the value of waste coming out of this. If you say from the operations and from the drilling operations, this is a large value. So we need to have a perfect handling and treatment systems in place. Otherwise, the drilling are done spatially, it will be spread across entire desert. So we are currently operating 33 rigs and expected to increase by 60 by 2016. So, as you know, ADCO, ADNA have a comprehensive HSE policy. They have very comprehensive policy and committed for the protection and conservation of the environment. In addition to this one, even at the division level, our drilling department, because looking into the activity level, they have a special waste management policy. So which ensures that zero discharges to the environment and application striving to use best available technologies, best available environmental practices, and also we are also committed to reduce the value and also toxicity of the waste produced in the system. So this to say that there is even the division level, there is a commitment and they have a dedicated waste management policy. Here, this is the total daily operations. I am not going to talk about the air emissions because I am going to talk about mainly about the liquid and solid waste. So drilling generates both liquid and solid waste. Coming to the liquid, there is a water-based mud coming from the after residual mud, and also we use a lot of saline brines for the well completion fluids, and oil-based mud and domestic sewage. And coming to the cuttings, there is a solid waste. Those cuttings are not hazardous because they are mixing with the fluids like water-based mud and oil-based muds. They are contaminated and it becomes an issue for us. So though we are using efficient solid control equipment, still there is a 20 to 30% of the oil content will be with the drill cuttings. So this has to be categorized as a hazardous waste. Generally we use here shale shakers, 3 to 4 shale shakers at each rig, and also hygiene dryer, and also we are using centrifuge to cover as much as mud and to reduce the volume of waste. And also I will be discussing about the new initiatives in addition to how we are practically doing this. Coming to the water-based mud and brine liquid, though the fluids water-based mud we use from well to well and recycle between the wells, but there will be at the end there will be unusable residual mud which is not able to recycle, we are injecting into two dedicated waste disposal beds. They are the waste disposal wells are in the deep reservoirs. Because if you see this is UR and Simsima, these are at 3,500 to 5,000 feet depth. And they are from the reservoir studies, it has been observed that their permeability is very high. So they can absorb a lot of waste. And also I can show you my next slide why this was not a, because it is a very hypersaline aquifer, so which is not going to be affected. So this facility, the two wells we have, actually these two wells are such that they are in between the fields. So to optimize the traffic and transportation, we also located the two wells in it such that the traffic should not be increased. This facility consists of storage tanks, which you see here, storage tanks. Then this is the injection well and the pumps. So this is the regional reservoir which I was talking. See, we are injecting into this two aquifers, which is Simsima and UR. So if you see the salinity of this is 160,000 ppm and 230,000 ppm. So even if our sea water, your Gulf water, the salinity is only 50 to 60,000, whereas this aquifer water is 160 to 2030. So it cannot be used for any other reservoir. We are committed for the shallow groundwater, not to exploit the shallow groundwater, which is the important source here, is the new aquifer. This is up to 500 feet, this is available. So no activities are taken place in this aquifers. So whatever injection is done here, even water required for our injection purposes, also we are taking this hypersaline water. Coming to the oil-based mud, we are using oil-based mud for the drilling efficiency, and in order to avoid disposal of the oil-based mud and also to ensure the recycling, we have established a dedicated mud treatment plant. And after treatment, again this mud is sent it for again to the rigs for the mud preparation. This plant consists of basically, here, this is first it has a receiving facility, which it is a loading and unloading, also measuring mechanism, and the quality will be tested, and it will go for the treatment. Like this, we have two centrifuges here. This centrifuge separates the solids, and the solids will come to these tips. Then it will go to these tanks. There they will be added some chemicals to again make the mud, the soil-based mud, for the reusable. And after that, this is the laboratory. There the quality control is ensured, and is again sent back to the rigs. So while transporting, also we use in order to avoid the leaks and things. So double hull tankers, it is ensured that double hull tankers are deployed while transporting from the rigs to this treatment plant. This is also centrally located to optimize the travel distance. Another liquid waste is like, this is the common waste, sewage, which is generated from the rig camp as well as from the rig site. So generally 100 to 150 people will be staying in camp. So they are also moving. So in order to ensure the sewage is treated, this package sewage treatment plant is deployed. This is a aerobic method, aerobic treatment process. It consists of one chamber here, aeration, then clarifier, then sand filter, and chlorination. This water again is collected here and used for either for dust suppression or for sometimes green belt. Because these are moving, so it is very difficult to raise. But if the permanent camp is going to be there for a long time, definitely it will be used for the green belt. Next thing is about solids now, how we are controlling the solids. So then you come to the water-based mud. Water-based mud is generally categorized as a non-hazardous because the toxicity of the water-based muds is not that much, it doesn't qualify as a hazardous waste. So when hazardous waste having less than, when the TDS or salinity of these cuttings is less than 16,000 ppm, we dispose on the rig site. Because we test that the desert, the soil quality, soil salinity is about more than 30,000 ppm. So it is not going to be even, it is going to even dilute the salinity. So in the non-sensitive areas, this is in the desert area. But if it is a sensitive areas, like we are also operating in the Agarbaya and some of the areas like Sapka, where the groundwater is very shallow, and sometimes we operate in the hill island like the biospheres, there no surface disposal is allowed. The entire cuttings, the water-based mud cuttings also transported to the other area which is non-sensitive area. This is about OBM cuttings. This is a major concern because OBM cuttings consist of 20 to 30% of the oil content in the cuttings, and about 10% is the analysis, and 60% cuttings. We have studied a number of options, like we have done a lot of studies, bioremediation, land forming, and injection, other things. But from our studies, we come to know that this is very good method of treating, because in thermal desorption, you are totally recovering the oil, and whatever coming out is a non-hazardous. So what we do is here we use the indirect thermal desorption method. So this is our thermal desorption plant, which we have last year we treated about 30,000 tons of tree cuttings. It has, because it has all the facilities like loading, unloading, and mixing facility. Because sometimes some wells it will be less oil content, some cuttings have higher. So in order to ensure blending, they will mix and fed into this kiln. This is a indirect. This is like without the here the heating is done without oxygen. So the heat is applied on the outer shell and the cuttings are inside. Then these volatile organics, VOCs, are vaporized, and the vapors are condensed. The condensed is taken into the recovered as oil. Then cuttings, whatever cutting is we are using for the construction activities. This, if you see this, the oil content in this is 0.1 ppm. It is 0.1 ppm or 1000 ppm. 0.1% or 1000 ppm. And the whatever water also used coming, because it is heated here up to 450 degrees. So it has some little bit heating. So that also we use for the cooling the cuttings, and also for the sometimes because it is an open area, so we have for the dust suppression systems. Whatever other waste comes from the drilling operations, other waste like chemicals, sometimes we have expired chemicals, some electrical things, or some lamps or some things. There is a ADCO facility. We have a BR facility. It is a centralized facility for all the ADCO companies, which is having range of treatment systems. If you see here, it has all these chemical, physical, all these systems. Like we have engineered landfill, which is a class A and class B, both are there. And if the materials are very active, the metals will be solidified here. And there is an incinerator, and also there is also a small thermal desorption plant. There is also physical treatment for the liquids, and also molecular distillation plant. Now we are also adding the NOM. Sometimes the NOM is also coming from that. Besides that, the NOM facility is also coming up. So this whatever waste we apart from the other waste, we will be disposing in this facility. Next thing is this is a new initiative. So what we done is that to make it a sustainable waste management practices, we had contacted the Lafarge. It is a very big cement company. It is working in 150 countries. They are also committed for the sustainability. They have they have come and taken our samples, OBM samples, and from the samples they found that these OBM cuttings can be used in the cement plant. And they come to that by using the cement cuttings in the cement process. There are two areas these cuttings can be utilized. One is because the cuttings are something but shale and sand particles, they can use it as a raw material. And and it contains about 20 to 30% of oil. This oil can supplement their fuel consumption, and it will be mixed and used at the end. The total thing is incinerated. Means there will not be any ash. In other cases, in other treatment processes, there is a end product which we need to again dispose. So this will ensure the total waste management solution. And this also have high temperatures like 1400 degrees, like furans or whatever engines, which is coming to be totally prescribed in this. So we are also doing a 1000 tons pilot project with them. This is one technique which I want to share. This is not completely related with the drilling, but this is with the oil sludge. This is what we do, when we have storing a lot of oil, like 5 days, 10 days storage, big tanks. There will be accumulation of the sludge at the bottom of the tanks, and it will gradually reduce the capacity. So in order to clean them, we have to desludge it frequently 5 to 7 years. So in our one of the export facility like Jabaldana, there used to be a lot of oil sludge generation because it was a disposal is not the favored option. So what we have done is that we have looked into the number of options. Then we come to know that this mechanical sludging with a decanter is the best option. So what we did is the tanks here we used the turbo mixers with adding crude, so that the hard particles will be made into a very semi-solid, semi-liquid, and in order to increase the viscosity of that, so that it can be pumped. Then the mixers are used and it is pumped to the decanter. This is a two-phase decanter. Then it is separated into liquids and solids. These liquids are going to the number of tanks are there, so it will go to the nearby tank, and solids will come collected in the tanks, these boxes, and send it for our either for the beyond facility or again for our thermal desorption unit, where we can totally recover the oil. So with this method, what we actually is that 50% of the time, earlier we used to the workers working in the tank, the workers exposure confined space center has been reduced by 50%. And if you see that the sludge generation, 70% of the sludge is generated is because we have recovered 70% of the liquid, the sludge generation reduced by 70%. So whatever cost we additionally incurred for this method is totally paid by this technology. So this was recognized by the ADNOC, HSC, ADNOC, and last year this was awarded the Best Innovation Award. So this is the conclusion. So ADCO is using best technologies, and also we are using best practices. Not to satisfy with, we are also exploring with a lot of new technologies as I explained.